Hey everyone, this is the Math Nexus, and today we are going to solve the past paper exercise, which is exercise 1.8. So, there's no new concept in this. It's going to be a revision of all the things we have done in this exercise till now. So, let's start the exercise. For question number one, this came in November 2011. And what we have is solve the equation 4x minus 5 in a modulus is equal to 21. And as we have solved this before, okay, now I will clarify the fact. I'm going to assume that you know everything. I'm not going to explain every type of question, as this exercise has the mixture of everything we have learned till now. So I expect you to have listened to each and every one of my lectures. And if you have done that, you will find this exercise really easy. So 4x minus 5 is equals to 21, or 4x minus 5 is equals to negative 21. We are doing this because we are opening a modulus, and when we open a modulus, we have two what you can see, two types of value, one positive and one negative. So just simplify this. 4x equals to 21 plus 5, which is 26, or 4x is equals to minus 21 plus 5. So minus 21 plus 5 is minus 16. So x is equals to 26 upon 4, or x is equals to 16 upon 4. So 4 ones are 4, negative 16 upon 4. So 4 ones are 4, 4 fours are 16, and 4 ones are 4, and 26 divided by 4 is actually 6.5. 6.5. So x is equals to 6.5, comma, negative 4. That's our two values, and that's it for question one. For question number two, we have part A, which says that we have to sketch the graph of y is equals to 3 plus 5x in a modulus, showing the coordinates where the graph meets the coordinate axis. So again, I don't think it's going to be much of a thing, but what you need to know is whenever we sketch a graph, what we do, we need some things. We need the shape of the graph, we need the gradient of the graph, we need the y or x intercept of the graph. Now we are going to take the y intercept. And of course, we need the vertex. I have explained each and every thing of these things. So what we do is first of all see the equation. If we compare this with the equation of straight line y is equals to mx plus c, it fits in. And if we say that this with the x coordinate, we have the gradient. So we have the gradient, which is m is equals to 5. The second thing we are going to find out is the point when y is equals to 0. Okay, so 3 plus 5x is equals to 0. And what we are going to do is we are finding the x coordinate of the vertex. How is that? Because I've told you we take out the modulus function and assign the value to be 0. It's explained in the modulus exercise. So 3 plus 5x is equals to 0. 5x is equals to negative 3. And x is equals to negative 3 upon 5. Okay. Similarly, for the y value of the vertex, we have to find when when x is equals to negative 3 upon 5, obviously. So we get y is equals to modulus of 3 plus 5 multiplied by negative 3 upon 5. I'm just going to solve that here. Multiply by negative 3 upon 5. We get negative 3. So 3 plus negative 3. So y is actually equals to 0. So our vertex is at the point 0. Our vertex is at the point negative 3 upon 5, 0. We have the gradient and we have the shape of the graph. And that's enough for now. Actually, because this is also our, what's it? It's our x-intercept. So it's not a big deal. I think this is enough. The gradient, the vertex, and the shape of the graph we have. Shape is a V shape. Okay, so let me just make the graph. Okay, so we have the graph, and what we are going to do next is, first of all, we are going to find the point where the graph meets the y-axis, because they have told us to show the coordinates of the point where your graph meets the coordinates axis. So when y is equals, when x is equals to 0, y is equals to 3, and it's positive 3. So another coordinate we are going to sketch is 0, 3. Okay, so our first point is at 0, 3, when x equals to 0, y is equals to 3. Here's our first point, and our second point is at when x is equals to negative 3 upon 5. What's negative 3 upon 5? It's approximately 0, or negative 0.6. So y is equals to 0 at that point. And let me just zoom it. 0.25. 0.25 is 0.5, and somewhere here it's going to be 0.6. So what we do is create a straight line from here up till here. We just make a reflection from this point. That's our, let me just increase it. It's going to go from this path to somewhere like this. Yes. Okay. 1, 2, 2.5 boxes here, 2.5. So yeah, this is our graph for question number 2. And it's really that simple. What they have asked us next is to solve the equation 3 plus 5x is equals to 2 in a model. So I told you before that this 2 value is, we are assuming it to be y. And we can absolutely find this through the graph itself. So when x is equals to 2, what we are going to do is, let me really just zoom in. And if you see, it is just before, if I can just highlight this, it's just before the line which says 0.25. We are going to take this thing down up till here. Okay. And if you can see, is I don't think if you can, yes. So now if you can see, it's just before 0.25. And the second point when x equals to 2 is here. Okay. It's going to be somewhere like here when x equals to 2. And if you take that line, something like here, it's a little more than negative 1, but we are going to assume it to be negative 1. Okay. So this is negative 1, and this is just before 0.25. So we can say this is negative 0.2, and our second value is negative 1. You can say, or if you want to say it's negative 0.9, something like that. So for question number 2, what can I do? Oh, I'll erase this part. For part B, we have x is equals to, because we are finding two values of x when the y value is equals to 2. So x is equals to negative 0.2, or x is equals to negative 1. Your value can be anything, something like near this. I'm using graph paper, so it's mostly accurate. But anything near this, if you have that value, it's correct. No problem. Okay, I don't worry. So that's for question 2. Let me proceed to question number 3. And we have in question 3 a similar question, which says we have to sketch the graph y is equals to 2x minus 5, showing the coordinates of the point where the graph meets the coordinate axes. And for part B, we have 2x minus 5 is equals to 3. So it's a similar question. And what we do is, what we have done till now is what is just say question 3a. Shape of the graph is a V shape. We know it because we have compared the equation. And again, I'm emphasizing, if you do not know what I'm doing, please take my previous lecture, especially for the modulus graphs and functions, because they are going to help a lot. And a gradient is y is equals to mx plus t. If we compare it with this equation, our gradient is 2. So gradient is equals to 2. Our third point is the vertex. We have to find the vertex. And how will we find the vertex? First of all, assign the function of x in the modulus to be equals to 0. Solve this equation to x is equals to 5, x is equals to 5 upon 2. Similarly, we have to find the y value of the vertex, and when x is equals to 5 upon 2, that value will occur. So 2 multiplied by 5 upon 2, more or less minus 5. So 2 and 2 will be cut down, and that will be equals to 0. So our vertex is at the point 5 upon 2, 0. We have the shape of the graph, we have the gradient of the graph. The last thing I think we will need to find out is it's going to be sorry, when x is equal to 0, meaning our y-intercept. Okay. So our y-intercept when x equals to 0 is going to be 2x minus 5, 2 multiplied by 0 minus 5 is equals to y, and minus 5 in a modulus is equals to y, and h in return is equals to 5 because modulus values become positive. So that's it. We have our vertex which is 5 upon 2, 0. We have our y-intercept which is at 0, 5. And we have our gradient which is 2, or specifically 2 upon 1, which means 2 is the rise and 1 is the front. So let me just sketch the graph for this. And for that, what we are going to do is zoom it up a little bit out and let me just complete this graph by 6. So what we are going to do is mark these points on the graph. So it's going to be 5 upon 2, 0. It's 5 upon 2. It's 2 to the 4. It's 2.5. Okay. So 2.5, 0. So when x equals to 2.5, y is equals to 0. It's going to be somewhere here. 2.5 is something like here. Okay. And our second point is when x equals to 0, y is equals to 5. That's our second point. Okay. What we are going to do just to give us a path, 2 rise, 1 run. We are using the gradient, by the way. 2 rise, 1 run. And that is going to help us with our graph. So make a line, connect these. Oh, yes. Yeah. Make a graph, connect these lines, make a perpendicular line, and then reflect it on the same thing. So we have 2 boxes here, and oops, I think it was. So that's it. This is our graph for question 3, and that's it. So for question 3b, what they've asked us is solve the equation 2x minus 5 is equal to 3. So when y is equal to 3, we have to find the 2 coordinates, and first coordinate is going to come here, and the next coordinate is coming here. So our values will be 1 and 4. So let me just check. Sorry, my calculator just went down. So for the values we have 11%. So yeah, our answer is correct. So one is for B, we have x is equals to 1, and the other value is x is equals to 4. So these are the two set of values we are getting when we solve the equation to x minus 5 is equals to 3. This is it for question 3. And okay, so for question 4, I want you to go a little back than the modulus functions when we were finding the range and domain of normal functions. And it's a function is said that fx equals to 3x squared minus 1, for x is negative 10 till 8. Now we have to find the range of f, meaning for these set of input values, what is the most highest and lowest value we can get out of a function. And the thing is, we could have done minus 10, minus 9. We could have found the output for each of the domain values, but that would be a really lengthy thing because from minus 10 till 8, there's approximately 18 and 19 values. It's a lot. So the thing is, what can we do? We use our brain. So the thing is, there is a 3x squared in this function. So that means either negative or positive. Whatever we value input in this x squared will come out as a positive value. Even if we input negative 10, we are going to get 100. And if we input 10, we are going to get 100 out of this x squared. So the thing is, we need to find what is the value that will give us the lowest value out of this x squared? And that value is obviously 0, because negative values can't affect this x squared. So what's the thing which is greater than a negative value but is lesser than a positive value? Yes, it's a 0. So what we do for the minimum value, whenever we see a x squared, we take the minimum value to be 0 if it is in the range of the domain. For example, if the domain would have been x is greater than 1, then we could not have taken 0. We would have directly taken 1 itself, because that's the minimum value. So, and for example, the equation could have been 3x minus. Then we could have taken negative 10. That would not have affected our equation, because negative 10 would result in minus 30, not positive 30. So for the minimum value, we are going to take 3 multiplied by 0 squared minus 1, which gives us minus 1. And for the maximum value, you can guess it. For the maximum value, we do know already that the negative value is not going to affect our answer. So is 8 squared greater, or is negative 10 squared greater? Yes, obviously 10 squared, negative 10 squared is greater. So what we do for the maximum value, we input 3 multiplied by negative 10 squared minus 1, which is in turn equals to 300 minus 1, which is equals to 299. And so the range of the function f is fx is greater than equals to negative 1, but it's lesser than equals to 299. And that's it. It's really that simple. And what is in our next question? We have to write down a suitable domain for f for which f inverse exists. So the thing is, they have asked us to tell a suitable domain for which f inverse has some value and it is not a 0, or you may say it is not giving out a math error or something like that. So in order to understand the question, we have to first find the inverse. Okay, what is the inverse? And if we know the inverse, then that will allow us to find out the most suitable domain for it. So, what was the first step? Assign y is equals to f inverse of x, and write the equation y is equals to 3x squared minus 1. Similarly, then step 2 is to change the x and y values, 3y squared minus 1, and then make y the subject. So x plus 1 is equals to 3y squared, and x plus 1 divided by 3 in our under root is equals to y. So that's the equation for f inverse of x. Now, if you notice, if we input any other negative value, for example, okay, if we input negative 1, I get it, we get a 0. That would mean that f inverse of x would not have a value. It means 0 specifically means no value, okay? So even if we input minus 1, we will get a 0 in this under root, which will give us no value at all. 0 does not have any value, you can say. And if we input any other value except of negative 1, for example, negative 2, negative 3, for example, if we input negative 2, if we input negative 2 plus 1, we get negative 1 upon 3. And that will make a math error, because in an under root, in an under root, you cannot a negative value. So that would make it incorrect. So any other value except negative 1 will give us a math error, and negative 1 itself will give us 0. So we can say, however, if we can say 1 plus 1 is 2, 2 upon 3, it's something. 0 plus 1 upon 3 is something. So we can say that forever, if x value is greater than, or even if it's equal to 0, we can say that is the suitable domain, because even if we have a 0 or we have a positive value, we will get a suitable answer. However, if we give any other negative value, either it's negative 1 or it's negative 100, it's not going to be a suitable domain for f inverse of x. It's going to give 0, or in other cases except negative 1, it's going to give a math error because it's a negative value. So that's it. That's it for question 4. Let's proceed to question 5. Okay, so question 5 tells us that we have two functions, and they have told us to input the value of the function f into the function g. And they have also told us that input 37 in the function f. So first of all, the first step is to solve the function. First of all, input the function f into the function g. Okay. For that, what we are going to do is directly write under root x minus 1 minus 3, put it in a bracket so that we are not confused, and continue your function g. Minus 2 divided by 2 multiply again the function f under root x minus 1 minus 3 in a bracket minus 3. Now simplify this by inputting the value 37. So 37 minus 1 is 36. So we can say under root 36 minus 3 in a bracket is minus 2 divided by 2 under root 36, put it in a bracket, minus 3. You can input in the calculator, or if you have some general knowledge, you can say that 6 under root of 36 is equals to 6 itself. So 6 minus 3 is 3 minus 2 divided by 2 multiplied by 6 minus 3 is 3 minus 3. And this can further simplify into 3 minus 2 is 1 upon 3 to the 6 minus 3 is 3. So 1 upon 3 is our answer for part A. And similarly for part B, we have find an expression for f inverse of x. So simply just find what is the inverse of the function f. For that, again, follow these steps. Assign y is equals to fx and assign the value here under root x minus 1 minus 3. Then the second thing you do is interchange the x and y values. X is equals to y minus 1 minus 3. And what we do next is make y the subject. So x plus 3 whole squared is equals to y minus 1. And x plus 3 whole squared plus 1 is equals to 1. And that's it. That's the inverse of our function f. For c, we have the inverse of the function g. And what's our function g? First of all, write it in terms of y. Y is equals to x minus 2 divided by 2x minus 3. Next step, interchange the x and y values. So x is equals to y minus 2 divided by 2y minus 3. Now simplify this to make y the subject. Multiply 2y minus 3 to xy minus 3x is equals to y minus 2. So that will give us 2xy minus y is equals to 3x minus 2, and make y the common. 2x minus 1 is equals to 3x minus 2, and y is equals to 3x minus 2 divided by 2x minus 1. I know I got a little speedy in this, but I hope you understand what I'm doing, because I'm expecting you to have taken the previous lectures of mine. Please bear it. And if you're not taking the previous lecture, I strongly recommend you to do so. Not because it's my advantage for that, I'm getting views or something, but it's going to clarify your concept. And that's what this channel is for, clarify your concept. Okay, so we have got this. We have got part B, C, and what we have to do is now, okay, there's no other part for this. Okay, so let's proceed to question number 6. Let me just erase this all. And first question 6 is a function g is such that gx is equals to 1 upon 2x minus 1 for the values of x is given. We have been given the domain. So we have to just find the range. And it's just 2 to 3 values. What we are going to do is just directly find it. So question 6, part A, when x is equals to 1, we have 1 upon 2 minus 1, which is 1 upon 1, which is 1. Then x is equals to 2. We have, what do we have? Please wait a second. So when x is equals to 2, we have 1 upon 4 minus 1, which is equals to 1 upon 3 in return. Similarly, when x is equals to 3, we have 1 upon 3 to the 6 minus 1, which is 1 upon 5. That's it. Now see which is the most minimum value. 1 upon 5 is the most minimum value. Okay, so 1 upon 5 is the most minimum value, and fx, or sorry, it's gx. So gx is greater than equals to negative 1 upon 5, but it's lesser than equals to 1. So that's it for part A. What we have been told in part B is to find the inverse of the function g. So we have done these types of questions. You can do that again. So b g inverse of x, y is equals to, first of all, copy the equation 1 upon 2x minus 1. Interchange the x and y values. So x is equals to 1 upon 2y minus 1. Make y the subject. 2y minus 1 is equals to 1 upon x. And 2y is equals to 1 upon x plus 1, and 2y. Okay, just say y is equals to divide by 2 from every value, 1 plus 1. So multiply x with 2 and multiply this 1 by 2. So it's going to be 1 upon 2. And if you don't understand it, let me explain this clearly. For those who have, no problems. But those who don't understand, I've done this by, we have 1 upon x and plus 1. And if you see, we have an imaginary 1 in the denominator. It's obvious. So whenever I want to divide this by 2, what I do is, for example, it's multiplying by 2 here. It's going to be divided by 2 at this point. So I'm going to divide the value of 2 with both of these. So 2 multiplied by x is 2x, and 1 multiplied by 2 will become 2. So it's 1 upon 2. So if I just simplify this, take the LCM, we have x extra, so we multiply this by x and this by x. So we say that x plus 1 divided by 2x is equals to y, or the inverse of the function. So this is for the inverse. What I'm going to do is it that I can solve the rest of the question. Okay, so we have been told to find the domain for the inverse of the function g, and I've told you in my previous lectures that whatever the domain of a function is, it is the range of a inverse of that function, and whatever the range of a function is, it is the domain of the inverse of that function. So we have already found out the range of g, so we can say that the range of g is the domain of the inverse of, and we have found out the range of g to be 1 upon 5. We can say it's 0.2 is greater than equals to g inverse of x, and it's lesser than equals to 1. So this is the domain for the inverse of that function. And d, we have g squared x is equals to 3. So it's an equation. We have to solve this and find the value of x. So what we do right now is we are going to input the function g into the function g and make it equals to 3. So for that, we have 1 upon 2 multiplied by, instead of x, we are going to write 1 upon, 1 upon 2 x minus 1. And then continue with the equation. If you want to simplify this, 1 upon 2 upon 2x minus 1 minus 1. What I'm going to do is just very quickly simplify it. 1 upon 2 minus, multiply minus 1 with 2x minus 1 after taking the LCM. So minus 2x plus 1 divided by 2x minus 1. What it's going to do is, it's in the third step, it's going up and multiplying with 2x minus 1. So 1 upon 2 minus 2x plus 1 multiplied by 2x minus 1. It's going to be equals to 2x minus 1 divided by 2x minus 2x plus 3. Okay. And then what we are going to do is make this whole equals to 3, because this is not going to be the final answer. The final answer is one value of x that we are going to find out. So this whole is going to be equals to 1. Until now, what we were doing is just to simplify this. And now the real thing. Let's begin. 2x minus 1 is equals to 3 multiplied by minus 2x. So that will become minus 6x plus 3 3s are 9. So 2x plus 6x is equals to positive 1 plus 9. So 6, 7, 8x is equals to 10 and x is equals to 10 upon 8, which in return is equals to 1.25. And that's our answer. Okay. That's for part D for question 6. Now let's proceed to question number 7. Okay, for question 7a, we have two functions, fx and gx, and we have to find f g4, meaning we have to input the value of the function g into the function f and input the value of x to be 4. So we have fx, let's write fx, and instead of x, write x squared minus 1 and plus 3. So now the second step is to input the values of x to be 4. So 2, 4 squared minus 1 plus 3. Simplify this, we are going to get 4 is 16, 16 minus 1, 15 plus 3, 15 multiplied by 2 is 30, and 30 plus 3 is 33, which in return is equals to FG4. That is it for part A. For part B, we are going to say that what would be the expression for which under root x plus 4 will come in terms of h and k. So if you notice, if we input x plus 4 inside the value of kx, we would get our answer. So we can easily say that if we input h into k, this expression will come up. So our answer would be khx. Okay. I've detailed lectures about these type of questions in my previous exercises. And for 2, we have x plus a. And if you concentrate right now, we do not have any x plus a here or anything that would make x plus a. However, we may need some specifications. We may have an inverse of that function, or we may have a square of a function. And if you concentrate right here, we have x plus 4, meaning if we just guess, is 8 and 4. Is there a connection? Yes, there is. What was the 8? And if we try to input h square x, okay, we got that. And if we input x plus 4 into x plus 4, so x plus 4 instead of x and plus 4. And if we just simplify this, we will get x plus 8. So we can say that h squared x is the correct answer for this. Again, there is no specific method for these type of questions. It's about training your mind to these types of questions. And how can you train your mind? Practice, practice, practice. Practice a lot. Okay. Part C. Part C is going to be a little bit tricky, I guess. So we have x squared and we have x squared minus 4. So we do not have anything minus 4 or we do not have anything, a squared. However, if we concentrate, what is the opposite of an under root? It's a square. And what is the opposite of x plus 4? It's x minus 4. So a person can guess we need an inverse, meaning we need the opposite thing for this. So if we find the inverse of the function h, what would it be? So we would say y is equals to x plus 4. We would interchange the x and y values, x is equals to y plus 4. And we would say that y is equals to x minus 4, which would be the inverse of the function h. And we would say, wow, we do have x minus 4, but still we need x squared. And for that, what we would say, we would find the inverse of k, because there's an under root here. So if we say, I'm just skipping step 1. So if we say x is equal to under root y, and make y the subject, so y is equal to x squared, because we will add squared on the both sides. And y will be cut down with the square. Okay. So y is equal to x squared. Now we have the two things we need, x squared and x minus 4. So the thing is, what can we do? We can say that if we input the inverse of the value of h into the inverse of the value of k. I'm sorry. If we input the inverse value of k into h, okay, into the inverse of h, what we are going to get? We are going to get x squared minus. So that's our answer. Our answer is going to be the inverse of the value of h will have the inverse of the value of k in it. Okay. So that's the answer. I know it may sound a bit confusing, but it is a confusing topic. So it will make you confused. So that's for question 7. If we proceed on to question 8, we have a similar question. Question 8, we have fx is equals to 2 minus under root x plus 5. Okay, and we have to write down the range of it. So simple, how do we find the range? We can see no squared values, no big deal. Just take the most minimum and most highest value. Okay, so what we do here is for x is equals to negative 5. Okay, so 2 is minus under root 2 minus 5 plus 5 is 0. So we will get the answer to be 2 itself. 2 minus 0 is 0. And for x is equals to 0. Okay, I know many of you would say that it's not great lesser than or equals to sign while you're taking 0. I'll come to that. Just bear with me for now. For x is equals to 0, and what we are going to do next is input the value 2 and minus under root 0 plus 5 is 5. So 2 minus 5 is something like, I'm not going to solve this. I'm just going to tell you through a calculator. 2 minus under root 5 is minus 0.23. Okay, we can say it's minus 0.23. Yeah, it's minus 0.23. But we are not going to take this value. 236 actually. Okay. What we are going to do is we are going to say that fx is greater than equals to or most minimum value. Oh, sorry. I'm sorry. Fx is only greater than 2 minus under root 5. We are not saying it's equals to because there's no equals to sign for 0. So we are saying that fx is greater than 2 minus under root 5, but it is lesser than equals to 2 because we have an equals to sign with minus. So that's it for question number 8, part 1. Part 2, what do we have? We have find f inverse of x and state its domain and range. Okay, now first of all, find the inverse of x. That's the first step. Follow step by step. Its domain and range is the second step. So inverse of x, first step, assign y is equals to the thing, 2 minus under root x plus 5. Interchange the x and y values, x is 2 minus under root y plus 5 to make y the subject. So x minus 2 is equals to minus under root y plus 5. Can take this negative value here so that it's multiplied by x minus 2. So instead of x minus 2, it will become minus x plus 2 is equals to under root y plus 5. It will become 2 minus x. So it will become 2 minus x whole squared is equals to y plus 5. And we are going to easily say 2 minus x squared minus 5 is equals to y. And that's it. This is the inverse of the function f itself. Okay. So what would be the domain? We've discussed earlier that the domain of a function is the range of its inverse, and the range of its inverse is the domain of the function itself, vice versa. Okay. What we are going to say is domain. What's the domain of this function? What is the range of this function we have found in part 1? So we are going to say our domain is our domain is going to be x is greater than 2 minus under root 5, but is lesser than equals to 2. And what is the range? It's already given in the question. So the domain is the range. The range we are going to say the inverse of f is greater than equals to negative 5, but it is lesser than 0. This is the domain and the range. Okay. For part 3, we have to solve fgx is equals to 0. Okay. We have been given the gx equation. Just input gx into f. So 2 minus under root, instead of x, we are going to write 4 upon x. 4 upon x plus 5. And this whole is equal to 0. So we are going to say minus under root 4 upon x plus 5 is equals to minus 2. Cut down these negative values. 4 upon x plus 5 is equals to 2 squared. 2 squared. And 4 upon x is equals to 4 minus 5. So 4 is equals to negative x. And because 4 minus 5 is negative 1. So x is equals to negative 4. If this is looking like a negative x, let's do this. So x is equals to negative 4. And that's our answer for question number 8, part 3. Proceeding on to question number 9. And what it is. Question number 9a, we have the function f is said that fx is equal to 3x squared minus 8x plus 5. And we have to show that fx is equal to 2x plus a squared plus b, where a and b are to be part. Okay, now, as this is a past paper exercise, little out of this chapter, if we talk about this chapter only. This type of question comes in the latest chapters, but I'm going to solve this with an easy method so that you can understand. So what they're saying that you have to find a and b, and we have to show this one. And one of the methods I'm going to use is one of the easiest one. So 2x plus a squared plus b have been given to us, and I'm going to use the comparison method. I have not been given my equation in this form, so why change my this equation to this form? What I'm going to do is simplify this equation. I mean, open up this equation. So 2xa plus b whole squared, that's the expression. I think you should know that a plus b whole squared is equals to a squared plus 2ab. Oops. So 2a. Instead of a, we are writing x. B is a itself plus a squared plus b. And what we are going to do is 2x squared, something like this. 2x squared plus 4ax plus a squared plus b. Okay. Okay, now we are going to compare. We have 2x squared, 2x squared. We are going to first of all take the values which have the coefficient of x. So only 4ax has the coefficient of x, 4ax, and so it should be equals to negative 8x as given in the question. So the coefficient of 8x is with the coefficient of with x we have the coefficient negative 8. Okay, so we are going to say 4ax is equals to negative 8x. Got the x values on the both sides. A is equals to negative 8 upon 4. So 4 ones are 4. 4 ones are 4. 4 twos are 8. So A is equal to negative. Similarly, on the other side, okay, we have been done with this. And whatever remains is equals to, is obviously equals to plus 5. So A squared plus B should be equals to 5 because other values have been taken. X is taken and x squared is also taken. So A squared plus B is equals to 5. That's the only, these two are the only values which do not, which are themselves not the coefficient of x or x squared or any other x value. So they are single. So a squared plus b is equals to 5. We have already found a squared, so negative 2 squared plus b should be equals to 5. And b is equals to 5. So negative 2 squared is 4. So 5 minus 4 will come here. b is equals to, wait a second. B is equals to 1. If I'm not wrong, let me check, double check it. Question. So, oh, I'm sorry. I did a mistake here. This whole was multiplying by 2. I just multiplied still to ax. This is also multiplying by 2 here. So 2a squared whole. And what we're going to do is make this 2a squared and make 2a squared, make this 2a squared. And let me erase the last 3 steps. I'm really sorry for the mistake. What I'm going to do is erase it here and do it here. So 2 multiplied by negative 2 squared plus b is equals to 5. And negative 2 squared is 4, and 4 2s are 8. So 8 plus b is equals to 5, and b is 5 minus 8. So b is equals to 5 minus 8 is negative 3. So negative 3 is, we have found a and we have found negative 3. And that's it for part 1 only. Okay, thing is the part 2 of this question 9 is a little bit complicated and hard to visualize what they actually want from us. So they actually want the suitable domain for which f inverse exists. And before I explain what the question is demanding, let me sketch the graph. And the following steps I'm doing, you are not required to do it, but if you do it, it's just good for you, I would say. So the thing is, before we start anything, I would like to introduce you the new formula. And many of you would be, I think, familiar with this. Y is equals to a x plus k. So in fact, sorry, x minus h plus k. Okay, and the thing is, this formula is the formula of the turning point. The turning point. And this is kind of a format through which we can all find the turning point. And the thing is, thanks to question number 9, part 1, we have found that format. So as we can see, our equation is fx, and so instead of fx, we can say y. Y is equals to 2x plus, so x minus 2 plus, in fact, it's minus 3. Minus 3 is equals to y, or in fx. So the thing is, as we can see in this equation, we can relate to it. Where a is equals to 2, we do not need a. So in this formula itself, y is equals to a x minus h plus k. The h value is actually the x value of the turning point. I'm going to write TP instead of turning point. And the k value is the y value of the turning. It's a little bit confusing. Why did we not just write x and y? Well, it's obvious we already have x and y. So we have to find another way. The thing is, we can say minus h, as we see here, is equals to minus 2. So h is actually equals to 2, not minus 2. And k is equals to negative 3 directly we can write. Now the thing is, what we have to do, we have found out the h and k values. So we can say our turning point is at the point 2 and 3. Okay. And through these values, we have found out our, what you can say, our graph. And I've made a approximation of a graph. However, the turning point is obviously accurate. And why have we gone through all this? Why have we drawn the graph and everything? Well, it's to explain you a new concept. And however, it's linked with the concepts we have learned till now. We have learned in the previous lectures that the inverse of a function has a 1-1 mapping. Meaning, if a function has a 1-1 mapping, we have an inverse. However, if it has a one-many mapping or many-one mapping, it only has a function. It cannot have an inverse. Okay, and that's the point. If we see right now, what they ask in the question is to find a suitable domain for which f inverse exists. So they are saying we have to find a suitable domain for which this graph is a 1-1 mapping. Okay, you can say that. They are saying it in other words. However, if we see here, and let me extend this graph, you can say that this graph goes like this and something. Let me just extend the graph. It's a little rough, but something like. Okay, and as you can see, these are just approximate values of the graph. This is not an accurate graph. Only the turning point is accurate. So back to the main concept we are talking about. The thing is, as we can see, this is a curve. And for example, if we take y is equals to 6 and we draw a straight line for visualizing, we have two x values. Okay, we get two x values, meaning that this the function cannot have an inverse, because for one input value of y, we are getting two output values in the form of x. And that's the thing. We have to change the graph in such a way that we get only one output value. So what we have to do is ignore one part of the graph. Okay. And how we do that? We take the turning point and cut the graph into half. And that's it. What happens now is that we can say at this point, let me see, x is 2. And after x, we take the value. So we can say that whenever x is greater than equals to 2, f inverse can exist. Why is that? That's because for one input value, and let me just draw some line here. If we take y is equal to 3, and from this point, we have one value, which means this one, which is actually the turning. If we take y is equal to 3 from this point, we have one value, no two values. And again, if we take y is equal to 8 from this point, we only have one value. And that's it. That's the main concept. So we are dividing the graph into a perfect graph so that we can satisfy the equation for having an inverse. So we can say x is greater than equals to 2, because that's the point a graph can has the turning point. So what is going to be, let me just erase it. And we can say for question number 9, part A and sub part 2, we have that whenever x is greater than or equals to 2, okay, f inverse can exist. And that's the answer. And that's it. By the way, it's not important that you need to draw the graph and everything. You can directly, if you, I'm just opening CapCut file. So the thing is, if you just identify this is the graph of a curve, and if you can find out the x value of the turning point, you can easily just say that if the graph is greater than equals to that point, the inverse of that function can exist. And that's it. Proceeding to part B. Okay, for part B, what we have is gx and hx, and we have to write the range of both of these. Okay, so for gx, we have the most minimum value to be 0, and anything that, for example, is greater than that is going to be a positive value. So first of all, just input the most minimum value we can have, 0 plus 4 is equals to 4. So we can say that if we input the lowest domain, we are going to get the lowest value of 4. So gx is actually greater than equals to 4. It can't be lower than that. And for the inverse of h, it's really simple. The domain, the range is actually the domain of h. So what is the domain of h? We have it. It's greater than equals to 0. So that's for part B. And for the part 2 of that same question, we have been given the copy of a graph, and we have to draw the graph of gx and g inverse of it. So really quickly, just take 0, 1, 2, and I'm going to take 3 also. And what it's going to give us is when x equals to 0, 0 squared plus 4 is 4. 1 squared plus 4 is 5. I'm just really quickly inputting the x values to find out the y values. 2 squared is 4 plus 4 is 8. 3 squared is 9. 9 plus 4 is 13. And these are the values for the graph of gx. And for the graph of the g inverse of x, we are going to just switch the x and y values. Instead of 0, 4, we are going to write 4, 0, 5, 1, 8, 2, and 13. Again, I'm emphasizing, if you're not taking my previous lectures, please do take them, as it's going to make no sense if you're taking this without the previous lectures. So these are the set of values. Now let's plot them on the graph, and I think I need a much more bigger graph for that. And let me adjust this graph for end. So 10, 13 we want. So 11, 12, and 13. So 11, 12, 13, and 14. And that's it. So now what we're going to do is just plot this point. First of all, for gx, we have when x equals to 0, y is equals to 4. So that's our first point. When x is equals to 1, y is equals to 5. Our second point is here. When x is equals to 2, y is equals to 8. We go up here. When x equals to 3, y is equals to 13. And all the way up to there. For the second graph, for the inverse of g, we plot the coordinates. When x equals to 4, y is equals to 0. 4, y is equals to 0, somewhere here. And x is equals to 5, y is equals to 1. So x is equals to 5, y is equals to. And when x equals to 8, y is equals to 2. And when x is equals to 13, y is equals to 3. So here's it. And before we connect these lines, what I like to do is just make the line for y is equals to x, because that's the line from which our graph is going to be reflected. That's the line. What we're going to do now is connect these points. So first point here, last point there. And what we're going to do is make the graph in such a way that our points are connected. And that's it. So this is our graph for the function g. Let me just label this freehand. This is the graph for the function g. This is y is equals to x, the line. And the last graph for the inverse of the function is going to be something like this. So this is the graph for the inverse of function g. And so this is our graph for question number 9. And what they've told us is to find the value of GHX is equals to 85. So that means we have to first, let me just get something else. So input the value of h into g. So instead of x squared, we are going to write 4x minus 25 whole squared plus, okay, and this is equals to 85. Well, calculator, we will use it a lot in this question, I think. So first of all, open this bracket up. A minus b whole squared is equals to, I think you should know it. Okay, I'll just use a more simpler method. 4x multiplied by 4x minus 25. You know what? I'm just going to take. So there is a minus b whole squared is equals to a squared minus 2ab plus b squared. That's a equation, and that's how you open actually a whole square. So what you do is 4, by the way, it's applicable to anything that is folded up in a square. For a square, we have 4x as a. We're going to put this in a whole square, minus 2 multiplied by a, which is 4x. B is 25 plus b squared, 25 squared. Plus 4 is equals to 8. Simplify this. 4 4 is 16, x squared minus 25 2 is 50. 54 is 200. And 200 multiplied by x plus 25 squared. I have to check this. 25 squared. Oops, sorry. 25 squared is 625. Plus 4 is equals to 85. 16x squared minus 200x plus 625 plus 4 is 629. And what we're going to do is take this 85 and put it here. So 629 minus 85 is 554. So plus 544. And if you see is equals to 544 coming in table of 16. Yes. And 200 divided by. So what we are going to do is make a common out of this. So what would be the common? 2 is the most suitable common. So 2 to 8 x squared minus 100x, 100x only, plus 544 divided by 2. That will give us 272 is equals to 0. And it's going to be further factorize 2. 4 to the 8, 4x squared minus 100x. Oops, sorry, it's copied. So minus 50x plus 272 divided by 2. That is equal to 136. And we can again take a common of 2. So 2x squared minus 25x plus 136 divided by 2, which is 68, equals to 0. Um, well, the thing is, we could have directly input this into the calculator. But what's wrong in that? We are just something unnecessary. So right now what we're going to do is only input 2x squared minus 25x plus 68 into the calculator, and we are going to get two values. X is equals to 8.5 or x is equals to 4. These are the two values of x for question 9 B part 3. Okay, now the thing is that x is equals to 4 is not a correct value. Why is that? Let me explain. So we are inputting the value of hx into g, meaning that uh, what can you say? The domain or the input value of the g itself should be satisfied. And if we input h4, we get 4 multiplied by 4, which is 16 minus 25. And 16 minus 25 is a negative value, specifically minus 9. So h4 is minus 9. And what we are simply doing is inputting minus 9 into G, which does not, satisfy its domain. The domain is a positive value or the value 0 itself. And if you see, if we, for example, input H is 8.5, okay, we would get in return 8.5 multiplied by 4, 8.5 multiplied by 4 and minus 25, we would get positive 9. Thus, the value negative 9 is incorrect. The value 4 is incorrect and 8.5 is the correct value. So we will say that we are going to say that x is not equals to minus 4. So thus, x is equals to 8.5 only. Okay, so that's our answer for question number 9. Proceeding on to question 10. Okay, for question number 10, we are asked to draw the graph y is equal to 2 minus x and y is equal to 3 plus 2x on the same graph. Okay, the thing is they have given us the axes and they have given us the limits also. As you know, I'm going to draw my graph on the virtual graph here, but the thing is I'm going to follow their rules. I'm not going to take any value which is greater than y value of 1, something like that. Okay, so what I'm going to do first is y is equal to 3 plus 2x. And this time I'm going to go a little bit different. I'm going to make a table for the set of values. And I know it's a bit lengthy, but it's more easier, I guess. Minus 6, minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 1, 2, 3, and 4, 5, and 6. What I'm going to do is make some lines there, separate them, and then I'm going to find the y values for these. So negative 6 multiplied by 2 is negative 12. Negative 12 plus 3 is 9. And well, it's a negative 9, but after it passes through our modulus, it becomes 9. So I'm going to really quickly input these values. So 5 2 is a 10, negative 10 plus 3, 7, negative 4 2 is a 8, negative 8 plus 3, 5, 3 2 is a 6, negative 6 plus 3, 3, 2 2 is a 4, negative 4 plus 3 is 1 after it passes through a modulus, obviously. So again, for negative 2 plus 3 is 1, even if it is in a modulus. So 3 plus 0 is 3, and then 3 plus 2 is 5, 2 to the 4, 4 plus 3 is 7, 3, 3 to the 6, 6, 7, 8, 9. And I won't take the rest of the values because 9 has come already. So no need for that. We are not going to exceed more than that. And for the second equation, we have y is equals to 2 minus x, and this follows the format y is equals to mx plus c. As this is a straight line, we are going to take some limited amount of values, around 2 to 3 values, negative 6, negative 5, and then 5 and 6. Those are more than enough to make a straight line. So for negative 6, we have negative 6 plus 2 is, what is it? Sorry, wait a second. Negative 6 multiplied by negative x is positive 6. So 6 plus 2 is 8. Negative 5 multiplied by negative 5 is positive 5. So 2 plus 5 is 7. And 2 minus 5 is minus 3. And 2 minus 6 is minus 4. So we have the values. Just let's plot these coordinates on our. Let me really quickly clear this. We're going to zoom in a bit and make it up to date. We want till 9, so that's not a big. Okay, so what we're going to do is plot these points. So negative when x equals to negative 6, y is equals to 9, negative 6, and all the way up till 9. When x is equals to negative 5, y is equals to 7. Here we go. Here is our second point. When x is equals to minus 4, y is equals to 5. When x is equals to minus 4, y is equals to 5. When x is equals to negative 3, y is equals to 3. And x is equals to negative 3, y is equals to 3. And when x is equals to negative 2, y is equals to 1. Then we have when x equals to negative 1, y is again equals to 1. And I will come to that in a bit, as this is forming some squared base. When x equals to 0, y is equal to 3. And when x is equals to 1, y is equals to 5. Similarly, when x equals to 2, y is equals to 7. And when x equals to 4, y is equals to 9. We see this up here. Okay. So what next? If we just connect these points, wait a second. I think oh yes. When x is equal to 3, y is equal to 9. I did a mistake. I bet. When x is equal to 3, y is equal to 9. So if we just make a line right now, really quickly, we get this. And according to me, what we have learned now, the shape of our graph should have been something like a V shape, something like this. So what's the problem in this modulus graph? And the thing is that we are actually, I've discussed one type like this question in my previous exercises. And the thing is, what we have to do is find the missing point. We are missing a point between two of these coordinates, which is really crucial. By the way, है ना सीधे पीछे आया था ना पता नहीं क्या अजीब सा बोला था वो कार्ड थे ना. Okay, so these 2 points are there is a point in between which is crucial for us, and obviously we are using a reflection of a graph, so that means between these 2 points that point will come. Okay, and if we just extend these 2 points like this, we are getting the point when x is equals to when y is equals to 0. Again, I'm explaining why I've said that between these 2 points we are getting a crucial point which is missing. And as this is going to be a reflection, we are going to create a perpendicular line just in between of these, and we are going to reflect this graph. Okay, so there's a crucial point between. What we'll do is we say when y is equals to 0, and we have to find the coordinate. So 0 is equals to 3 plus 2x, and negative 3 is equals to negative 2x, and cut down these negative symbols. 3 upon 2 is equals to x. Which is specifically is 1.5. 3 upon 2 is 1.5. Yes. So we are going to get a point negative 1.5. By the way, why is it 1.5? Let me see. I think I've done a mistake here. Negative 3 is equals. Oops. There wasn't a positive here. Sorry, my bad. So this is a positive 2x, and these negative symbol will not be cut down. It will remain negative 3. So negative 3. So negative 3 upon 2 is equals to x, which is equals to negative 1.5. So at negative 1.5, our reflection is coming, and that's why it's crucial to find out the vertex. And that's it. We did not find the vertex, and we paid for it, and we had to do something wrong. And if you would find the vertex, it would be 1.50. Okay. Now this is the graph for 3 plus 2x in our models. The next thing we do is find the make the graph of y is equals to 2 minus x. And let me just erase it. This space will be needed. Okay, so y is equals to 2 minus x. Just plot the coordinates. When x equals to minus 6, y is equals to 8. It goes all the way up here. Minus 6 and 8. When x is equals to minus 5, y is equals to 7. Goes all the way up here. It's going to intersect at that point. When x equals to 5, y is equals to negative 3. So when x equals to 5, y is equals to negative 3. Yes. So x equals to 5, y is equals to negative 3. And when x is equals to 6, y is equals to negative 4. Let me just make this a little. And then what we'll do is make the line for this. Make a straight line. And yes, there's the line. And let me just this is the line y is equals to 2 minus x. This is the graph for under 3 plus 2x is equals to y in our models. And now that's what part 1 required from us. What part 2 requires is to solve the equation 3 plus 2x is equals to 2 minus x. Well, we could have done this 3 plus 2x is equals to 2 minus x, and then took out the 3 plus 2x is equals to 2 minus x, or 3 plus, and the other process. What we could do is simply use the graph and find out the intersection points. So our first intersection comes at this point, and another intersection is at this point. And specifically, if we just use our line tool to just go down, it's negative 5. And here, so it's negative 5, 7, our first point. And let me just zoom in for this. So it's coming from approximately 0.3. So the two values of x is negative 0.3, or it's negative 5. And just let me just check these values. And yes, I'm correct. Negative 1/3. Yes, so that's it. This is for part 2. We have the two x values, and I hope you enjoyed this lecture. And I will meet you in chapter 2. This is the end of chapter 1, and actually chapter 1 ended in exercise 1.7. This is actually the past paper exercise, but still, congrats, we have completed our chapter 1, and meet you in the next lecture with chapter 2.